Assalamu alaikum all. Can you hear my voice? Can you hear me? Yes, what about others? Are you with me? Can you hear me? Okay. So we have already started chapter number 3, that is basic foundations, standards, models, and languages. First of all, I would like to make an announcement regarding your assignment. There is no need to do Blackboard assignment. We will be giving you our own assignments. So we will give you, inshallah, 4 assignments and 1 case study. And your first assignment will be given on 15th of Feb or after 15th of Feb. So there is no need to do Blackboard assignments. Okay? Yeah. So this time we will be giving you our own assignments, and inshallah it will be beneficial for you, both from exam perspective and from your knowledge perspective. And 1 case study will also be given to you. Yes, it is listed in Blackboard. 4 assignments will be given to you and 1 case study. That is total 5 things you have to do in this semester, in this course. IT 340 Network Management. Okay? So we have started chapter number 3, Basic Foundations, Standards, Models, and Languages. And we have seen that these are needed to build network management based on various standards. And we have introduced those standards. And network management standards that are currently used are SNMP, that is Internet, CMIP, which is used in OSI, TMN, IEEE, and web-based management. Of these, SNMP is most widely deployed management system due to its truly simple architecture and implementation. And inshallah, we will discuss SNMP in more detail in the coming chapters. And we have seen the overview of models, and the concept of network management is also covered. And inshallah, in today's virtual session, we will see the specifications of most protocols using ASN.1 syntax, and it will be discussed in detail. So we have discussed this. So there are 4 models, of which we have discussed the first one, that is organization model. And now next is the information model. And it is concerned with the structure and the storage of information, as we have seen that, for example, information is structured and is stored in a library, and it is accessed by all. So a book is uniquely identified by an international standard book number, that is ISBN. It is generally 10-digit number identification that refers to a specific edition of a specific book. So next we have chapter and figure number also. So we have a hierarchy of designation, that is we have ISBN, we have chapter, and then we have figure, which uniquely identifies the object, which is a figure in the book. So it defines the syntax of the 3 pieces of information associated with the figure. and the definition of their meaning in a dictionary will be the semantics which is associated with them. So as I have told you, we have two things that we have to consider. The first thing is the syntax and the second thing is the semantics. So the representation of objects and information that are relevant to their management forms the management information model. So the information model basically specifies the information base to describe the managed objects and the relationship between the managed objects. So the structure which defines the syntax and semantics of management information is specified by the structure of management information, that is SMI. So the information base is also called management information base. Management information base, that is MIB, and MIB is used by both agent and management processes to store and exchange management information. So as I've told you, what is an agent? Agent is basically when we talk about managed objects, then in case of managed objects, we have some management data which is running inside it continuously, and that is nothing but that is an agent. So here we have an agent MIB, and the MIB associated with the manager is designated as the manager MIB. So the manager MIB consists of information on all the network components that it manages, whereas the MIB, which is associated with an agent process, needs to know only its local information, that is its MIB view. For example, let's take an example. Means a country may have many libraries. So each library has an index of all the books in that location, that is we call as MIB view. So, however, the central index at the country's main library, which manages all other libraries, has the index of all the books in all the country's libraries. So, this is called Global Manager MIB view. So, the network configuration includes the MIB that is associated with the manager. And the manager has both the management database, which is MDB, and the MIB. It is important to distinguish between the two because the MDB is a real database and it contains the measured or administratively configured value of the elements of the network. And if we talk about MIB, it is a virtual database and it contains the information which is necessary for processes to exchange information among themselves. Now next, you can see this is the management database and the information base. It shows the distinction between MIB and MDB by considering the scenario of adding a component to the network. And here we have assumed that all the hubs in the network are made by a single vendor. NMS? Yes, Network Management System. So we have discussed this managed object. It can be any hub it can be bridge, it can be router. It has a software which is continuously running inside it, and it includes programs and algorithms. And then we have administrative information inside it. Now you can see this is a management information tree, and here the managed objects are uniquely defined by a tree structure specified by the OSI model and are used in the internet model. So this figure shows the generic representation of the tree defined as the management information tree, that is MIT. So there is a root node, as you can see. This is the root node, and well-defined nodes are there. These are the nodes. Underneath each node at different levels. So we have level 1, level 2, and level 3, etc. So each managed object occupies a node in the tree. In the OSI model, the managed objects are defined by a containment tree representing MIT. So this shows the internationally adopted OSI MIT. Let me show you the figure. This one. This is the OSI MIT, internationally adopted. And the root node does not have an explicit designation. The root has 3 nodes in the layer beneath it. As you can see, we have 3 nodes. And we have ISO, CCITT, ITU, and ISO, CCITT, ISO, ITU. It's not clear. Please. So first we have ISO, CCITT, ITU, and we have ISO, CCITT, which is also called ISO, ITU. So the ISO defines the International Standard Organization, and CCITT, is it related to the layers? Yes. This is related to layers. So it defines the International Telecommunication Union. The 2 standard organizations are on the first layer, defining the managing objects under them. The joint ISO ITU node is for management objects, which is defined not only to levels. Yes, Seher, what's your question? Can you please repeat? As you can see over here, we have layers. The 2 standard organizations are on the first layer, and it defines the managed objects. So this is basically information tree. And when we talk about tree, obviously it has layers, because in tree structure what we have a hierarchical structure, we have a root node, and then we have child nodes, and then we have branches, and again we have sub branches. So when you are talking about tree, obviously we have levels. Okay, we start from level 1, 2, 3, 4, and generally root is at level 0. As you can see over here in the previous case, see, this is the root node, so this is at level 0. Okay, and as we move downwards, we have level 1, 2, 3. Okay, likewise here also. we have labels. So here what we have, the two standard organizations are on the first layer and it defines managing objects under them. And the joint ISO ITU node is for management objects, which is jointly defined by the two organizations. The number in each circle identifies the designation of the object in each layer. And so it is designated as 1, 1.3, you have 0, 1, 2, 3, 6, 1, and so on. So all internet managed objects will be that number followed by dots. As you can see, we have ISO 1, then we have ORG 1.3, see here. Then we have DOD, that is Department of Defense 1.3.6. And then we have Internet 1.3.6.1. So ISO is designated as 1, ORG is designated as 1.3, DOD is designated as 1.3.6, and Internet as 1.3.6.1. So all the Internet managed objects will be that number followed by more dots and numbers. So it is to be noted that the names of the nodes are all in lowercase letters as a convention, and it is accepted worldwide. Now in object type and instances, what we have, in type we have name, we have syntax, definition, status and access, and we have instance. Now you see the managed object perspective. So we have a managed object which need not be a physical object that can be seen or it can be touched. So it is convenient to use a physical representation to understand the characteristics and the operations which is associated with a managed object. So let us consider an object which is circular in shape. We can define the object in English language syntax as circle. So we can say circle is used to show an object. To associate a meaning with the object name circle, we can use Webster's dictionary definition. So we have a plane figure bounded by a single curved line, every point of which is equally distant from the point at the center of the figure. So you can see we have axis, we have syntax, we have definition, which is also called semantics, and then the status. So we can define the basic objects that are required of a group of objects as the status of the object, and whether it is mandatory or optional to have that object. So this attribute of the object is called as the status. And there could be many types of objects that are represented by circle. So there's a unique identification and name. And this is called object identifier and descriptor. So we have object ID and descriptor. It is the unique ID and the name for the object. Then we have syntax, which is used to model the object. We have access, which shows the privilege to the managed object. We have a status, which is the implementation requirements and the definition, that means the textual description of the semantics. So you can see here the conceptual OSI representation of various characteristics of a managed object. So OSI specifications are object oriented, we all know that, and we also know that a managed object belongs to an object class. Objects, these are objects. See, the one which is represented by circle. Seher, can you see these circles? This circle? So whenever we have circle, that means it is an object. We are representing it with a circle. Okay. Object, you know, any entity. Any entity. Good. So what we have this managed object from the OSI perspective, and it presents the same circular object in the OSI model, and the definition of an object is, in an object-oriented perspective, will include both the shape as well as the values. So the attribute of the object in a circle with given dimensions, the attribute of an object defines the external perspective of the object. It undergoes an operation which is known as push operation, and push is not really an OSI operational entity but is used to illustrate the concept. And the behavior of the object is to change its shape or attribute from a circle to an ellipse. So that's why you have an ellipse over here. And it then sends the notification to the relevant community informing about its change. So the characteristics of an OSI managed object are, we have an object class, we have attributes. Attributes, you know, what is an attribute? What do you mean by attribute? I think you have studied it in database. Characteristic. Good. Properties. Good. Attributes means characteristics, or we can say properties. Now next, what we have operations which will be applied to them. We have behavior, and then we have notifications. So we can see that the characteristics of the managed object in the internet and the OSI model on a one-to-one basis, they are different. So it can be observed in the conceptual models that the OSI characteristics, we have operations, behavior, and notifications. They are a part of internet communication model. So operation in the internet is done by get and set commands. We have get command, we have set command, and these two commands are used for operation in the internet. So notification is done by response and alarm messages. The syntax characteristics of the internet is part of OSI attributes. Let's see the next slide. You can see the access characteristics of the internet is a part of security function in the OSI functional model. The status characteristic of the internet is handled by conformance as a part of application services in the OSI. You can see what characteristics we have. We have object type, we have syntax, access, status, and description. This is an example. As an object type, we have PKT packet counter, syntax is counter, access is read only, status mandatory, and description is count number of packets. So this is from internet perspective, and from OSI perspective, we have again same characteristics, but here we have object class, attributes, operations, behavior, and notification. This is packet counter. Attribute is single valued. Operation is get and set. Behavior retrieves or resets values. And notification is generates notification on new value. So this figure basically shows the comparison between the internet and OSI specification for the object packet counter. So packet counter is a managed object in the internet model. The object type we have seen as PKT counter, and these are the different characteristics. And the example of same counter as a managed object in the OSI model is shown in second figure, and we have seen the different characteristics and the example corresponding to them. So this is the comparison that we have already seen in the previous table, internet versus OSI managed object. Now next we have communication model. Now we have seen that management data is communicated between agent and manager processes, as well as between the manager processes. So three aspects needs to be addressed in the communication of information between two entities. So firstly we have transport medium of message exchange, that is the transport protocol. Next we have message format of communication, that is the application protocol. And thirdly we have actual messages, that is commands and responses. So this figure shows the management message communication model, where we have a manager which has applications, we have an agent which has network elements or managed objects. Here we have notifications, we have responses, and we have requests. So this figure basically shows you the communication model. The application in the manager module initiate the request to the agent in the internet model. It is part of operation in the OSI model. The agent executes the request on the network element, that is managed object, and returns responses to the manager. The traps or notifications are the unsolicited messages such as alarms generated by the agent. Now this figure shows you the communication protocol which is used to transfer information between managed object and the managing processes, as well as between the management processes. So the OSI model, which uses CMIP along with CMIS. Remember CMIP? Common Management Information Protocol. And as I told you, CMIP basically provides some services, and these services are called CMIS, Common Management Information Services. Okay. So the internet uses SNMP for communication, and the services are part of operations using the request, responses, and the alarm notifications. So OSI uses both connection-oriented and connection-less protocols for transportation. For example, we have TP4, Transport Layer Protocol, and could be used for connection-oriented transporting and application messages. We have TP4 over Connection-less Network Protocol, and it is used for connectionless transportation. So the internet uses connectionless UDP/IP protocol for transporting messages. Now, CMIP and SNMP, they specify the management communication protocol for OSI and internet management. Now next we have Abstract Syntax Notation One, that is ASN1, and in both information model and the communication model. Okay, Hala, no problem. I understand you have an internet connection problem. That's why you are sometimes signed out and signed in the session. No problem. But this session is recorded and you can hear it later on. So please hear this session later on. It's recorded. Okay. So in both information model and communication model, we have address functions. And in these models, SMI needs to be specified syntactically as well as semantically. So it is important for communication among systems that a formalized set of rules is agreed upon on the structure and the meaning of the language of communication, namely syntax and semantics of the language. So there are numerous sets of application and transport protocols, and it is beneficial to choose a syntactical format for the language that specifies the management protocol in the application layer. So we have ASN.1. So it is more than just a syntax. It is a formal language, and which was developed by CCITT, and now it is called ITUT, and ISO for use with application layer for data transfer between the systems. It is also applicable within the system for clearly separating the abstract syntax and the transfer syntax at the presentation layer. So we can define the abstract syntax as the set of rules which is used to specify the data types and the structures for the storage of information. Now you can see this Backus-Nauer form. We illustrate the Backus systems by developing a simple arithmetic expression. Now here we have some rules. So we can define an entity, digit as this is an entity, and this is the definition of this entity. Next, we have this symbol, as you can see, O, 0, then we have slash, then we have 1, then again we have slash. So this basically represents OR. This is OR symbol. This is an OR symbol. So digit has these values, that is 0 or 1 or 2 or 3 or 4 up to 9. So this is basically OR operation. Now here you can see we have number. So number is again an entity and it is constructed from the primitive digit. So we have number or we have digit number. So for example, we have number 9 and it is a digit. So the number 19 is the concatenation of digit 1 and number 9. You can see. And if we have number 619, it is the concatenation of 6 with number 19. So we can construct simple arithmetic expression that is called SAE from the primitives and the construct number. So we have SAE. SAE stands for simple arithmetic expression. SAE is simple arithmetic expression. So we have SAE is equals to number, then SAE, SAE, OP, SAE. OP is the operation entity. And which operations we have? We have addition or subtraction or multiplication or division. Now you can see we have two assignments. We have Boolean type. So we use plus here. Where plus? Here. It has all these expressions. So we can choose any one of them. 9 plus 1. 9 plus 1. Not 9 plus 1, it is 1 plus 9. So here we have 19, 1, 9. So it is the concatenation of 1 and 9, right? To have 1, 9. It is 1 plus 9. It will be 1 plus 9. Okay? If we are talking about 19, so it is 1. If you are talking about 91, then it is 9 plus 1. Okay? So the place of digits is very important. You cannot interchange the place, otherwise it will be incorrect. So it will be, if you are talking about 1, 9, 19, that means it is the concatenation of 1 and 9, that is 1 plus 9, right? Clear? Good. So now you can see over here we have assignments. We have Boolean type is equals to Boolean, and we have Boolean value is equals to true or false. So the expression on the left side specifies the name of the type, and the right side, this one, is the definition or the value of the type. So Boolean type is defined as Boolean, and Boolean value is defined as either true or false. So the above examples illustrate the two basic parameters which is associated with an entity. So we have data type and we have value. Now you can see here we have a group of assignments which make up ASN.1 module. For example, a name consists of first name, middle name, and last name. So this can be specified as person name, is equals to, then we have curly braces because we have multiple statements. Then we have first John, middle T, last Smith. So here person name begins with letter and it is the data type. Person name is a module and it begins with the capital C. It begins with the capital letters, and the module comprises of 3 assignments whose names are first, middle, and last. And they have values John, T, and Smith. You can see. This shows example of ASN.1 data type definition. This is ASN.1 module defining the data types. These data types are personnel record, because they are modules, so they start with capital letters. Now, personnel record describe the personnel record of an employee in a global corporation. And it has title, it has division, marketing, then research and production, and their corresponding values. Now you can see here we have title and it is equals to graphic string. So the data type whose name is title is defined in line as the data type graphic string, and it can be defined as data type title as follows, like this. Now, if in personnel record, the person works in one of the 3 divisions, that is marketing, then research and production. So this is built using choice construction, where we have choice. And in each of these divisions, research could be either product-based or it can be basic. So the constructs set and sequence are list builders, and the personnel record module is a set of data type which includes name, it includes graphic string, sector, country, etc., which are all different data types. So since they are different and each is uniquely associated with a name, they can be encoded and transmitted in any order. Now you see this is very important. This table is very important. This table shows you ASN.1 symbols. This is the assignment symbol. Next, we have OR symbol. This is for signed numbers. This is for comments. This shows the start and the end of list. This shows the start and the end of tag. This is the start and end of subtype, and this is the range. Next, we have some keywords, which is important. That is choice, It shows the list of alternatives. Then we have set. It is for unordered list maker. Then we have sequence. This is the ordered list maker. We have off. This is used with set and sequence. And we have null. This is basically a placeholder. Yes, this is important. So you have to study it properly, the keywords and the symbols that are associated with ASN.1. So, like the previous example, yes, it can come. This is important. This is the convention that you have to follow. For object name, the initial lowercase letters are used. For application data type, initial uppercase letters are used. For module, initial uppercase letter. For macro and module, we have all uppercase letters, and for keywords, we have all uppercase letters. So this is the example for each one of them. And it is important to remember these conventions which are followed in ASN.1. This shows you the object and data types. As you can see, here we have data type structure. And this has several layers. It has a structure, it has tag type, and it has some other types also. You can see it has simple, structured, tagged type, and other. Now, if we talk about simple type, it is for which the values are specified directly. So we can define a page of a book as page number of simple type, which can take on any integer value. So integer is a simple type, we can say. Now next we have structured type. Now data type is defined as a structured type, and it contains other types also, like the types that are within a structured type are called component types. So a page number of a book could be defined as a structured type by a sequence construction of chapter number and page number. So it forms a structure. Next we have tag type. And as we know that data type has a unique tag which is associated with it. So a tag data type is defined to distinguish types within an application. For example, we have invoice number. And invoice number is an integer type. So it could have assigned a local tag ID. It can be a universal class with a tag number, or it could have been assigned a local tag ID. So this is sometimes done to improve the efficiency of encoding. And lastly, we have the category called other. And this is not predefined. It is chosen from choice in any types, so which are contained in other types. So suppose we have type choice, which defines the selection of one value from a specified list of distinct types. So we have a research which uses a choice construct to select one of the two alternatives between product-based and basis. So we can represent them with specific values instead of null. So this comes under other type. So please go through it, and if you will have any problem, inshallah, we will discuss it. This is very important chapter. Go through all these models and especially go through ASN1, and if you will have any problem, we will discuss it. Inshallah, we will meet in next face-to-face lecture in which we will discuss chapter number 4. Go through these chapters also, chapter 1, 2, and 3. And if you will have any problem, we will discuss it, inshallah. Till then, take care all of you. Assalamu alaikum.